So we are working in page 198 today. Go to the example 4, please. The example 4 is about matching scatter plots to situations. We need to show the scatter plot that best represents the relationship between the number of days since a sunflower seed was planted at the height of the plant. Okay, so in this example, we don't need to solve more on the board. We are only going to show what of these graphs is going to represent the situation described in the problem. So the situation is the number of days since a sunflower seed was planted in the height of the plant. Okay, in the first one, you have a positive correlation between the number of days and the height because the plant will grow each day. This is for the first one, the graph A. You have the time in days represented, 0, 20, 40, and 60 days, and you have the height represented in inches. The graph A has a negative correlation, so it's incorrect. So, okay, do you remember the form of the negative correlation? It starts like is in the top and later is like decreasing. So in the first part, you see that it remained constant in the first days, but later it's like it's decreasing. Look at the last 2 points. The last 2 points are decreasing, so the graph is incorrect. In the graph B, neither the number of days for the plant can be negative. You have negative 20 located in the X, you have the negative part of the Y too. So this cannot be the answer for what you are looking for. You are looking for the growth, you're looking for the height of the plant in a certain number of days. So you cannot represent in this case using this graph for the plant because you cannot have a negative height or a negative amount of days. So neither of they can be negative. Okay, the last graph has to be the correct, but why is going to be this the correct? Because the graph shows all the positive coordinates and a positive correlation between the number of days and the height. You start from 0. Remember, you plant the seed, so it's going to start growing, but if you need to grow, the plant needs to grow every day, okay? So in constant way. So this graph is what shows the positive correlation and it represents the data we have. So the graph C is the correct scatter plot. Now in the example that says check it out, we have a very similar situation. We need to show the scatter plot that best represents the relationship between the number of minutes since a pie has been taken out of the oven and the temperature of the oven. Okay, so in the graph A, we have the temperature is decreasing and the time is increasing. In the other part, the temperature is decreasing, but you start with negative degrees. If it was in the oven, you cannot have negative degrees because the temperature was too high. The temperature was high, so you cannot be decreasing the temperature. Even if you start in the negatives, it means that you are increasing the temperature to the positives. So the graph doesn't make any sense in this case. You start with negative 10 minutes, and again, how could be the time be negative? So no. In the third one, the graph C, the temperature is increasing. If you take the pie out of the oven, the temperature cannot increase. So the correct option, or at least the most approximated option, is the first one, the temperature 1. Okay, guys. Okay. Okay. If we don't have questions about the example 4, we can go to the example 5. I want to represent this with you. This is the last example we have. I think that you are clear with the exercises. Guys, if you have any question, you can talk and you can ask. You are not asking about this exercise. I assume that you are understanding everything. And it's because these kind of exercises are easier. I think that you don't have any problem to graph, to read the representations when they give you the graph. That's all you need. If they give you the graph, you are going to represent what is happening about this graph. And if they give you the information, so you are going to represent using the coordinates from for the x and for the y. So in the example 5, the fundraising application, you have the scatter plot. The scatter plot shows a relationship between the total amount of money collected and the total number of rolls of wrapping paper. Wrapping paper sold as a school fundraiser. Okay. So based on this relationship, predict how much money will be collected when 175 rolls have been sold. The fundraiser is to obtain money, okay? So we have the money raised in the y-axis, and in the x-axis we have the rolls sold. So we need to predict how much we are going to obtain in 150 rolls sold. 175, right? Because you don't have the part that's in 200. You don't have the 200. The last fact you have is 175. But you can see that in this graph, it's increasing. You have a positive correlation. So if more rolls are sold, you are going to have more money. So, okay. The other is the fundraiser. We can graph this and we can see the representation, but I want to read it with you first, and later I'm going to explain. If you draw a line that has about the same number of points above and below it, your line may or may not go through data points. We need to find the point on the line whose x value is 175. Remember, this is representing the x value because x is the rolls sold. And later the corresponding y value is, and you are going to find it on watching on the graph. But you can continue watching the grid. If you place 1 point in 150, where is going to be located the part for y? If you draw the line, the point in here it was is located approximately in 1200. So it's based on the data. You have to check on the graph in this case. I'm going to write the points with you so we can see it better, okay? We need to draw the graph, and we are going to find an approximation for the money collected if we have 175. We're starting here with 50, 100, 150, and the last one is 200. Okay. In this, you have a scale of 200 in each one. It's 200, 400. I think we need more space. 200, 400, 600, 800, 1000, and 1,200. Okay, and the points were, how are located the points? You have for 200 in here, less than 50. Later for, in here you have 300. For the next one, I'm only copying the same graph you have, okay? The same graph you have on the book in page 199. I'm only representing the points, so later I'm going to show you what happened with this graph. Okay, when you have 75 in here, you have almost this. Now, the other point is when you have 100 and you have 7 here. Okay. The other one is 150. No, I need more, one more. 125 and you have 900, okay, like in here. And the last one is for 1,000, I have 150. When you extend the line, remember that my graph is not going to be exact because I don't have any grid. I don't have a grid like you have on your book. But this is going to be located in here. And how can you see the form or the shape of this graph? It's going in this way, right? It's a line. It's completely increasing. You start in here from closer than 0, and you are increasing this. So if you increase the line more, and you have in here, 175 has to be located in here, between 150 and 200. So if you place one point in here, and you keep with this line, where is going to be located? It's going to be located closer than this point you have in here for the y. The y is 1,200. And you are going to locate this for the 175. This only you only obtain this looking at the graph. And it's an approximation based on the facts you have on the book. It doesn't have to be the real value. It could be, for example, 1,195, 1,205. Do you understand? This is an approximation using the graph. And the best approximation we have in here in this scale is 1,200, or you can read it like 1,200, okay? For 175. This is the scatter plot. Remember, when we have a scatter plot, they are points that are separated. They are not like a line. They are not like a graph, like a continuous graph. A scatter plot is a discrete graph. Why is discrete? Because I told you again, the points are separated, and I only have the graph for some points, some of the points. I don't have the value for all the points. For example, I don't know what point is located between these two, or what happened with all this, what happened in all this space. We can find more points to represent this on the graph, but you are not going to obtain all the values, including in here for example, the numbers in the, you only have whole numbers in here. But if you want to represent rational numbers, okay, so you are never going to have all the values when you are working with a scatter plot or with a discrete in this case. I was going to write discrete again, but you already know it. We learned about the discrete graphs in section, I think it was section 2.1 or 2.2. Okay, guys, about these graphs, Do you have any question? If you don't have any question, we can finish the topic in here. I think that is no big deal for this. If you have any question, you can write to my email, okay? I'm going to write my email again because Natalie doesn't have it. So, Natalie, are you here? Natalie? Or she went
Yes,
off?
no, no, yes, I'm
Okay.
here.
Natalie, I'm going to write you my email. Please write to me, write an email to me today so I can have your email too, because I'm going to communicate and send homework to you later. Okay, maybe not today, but the other days, and I want to be sure that I have your email. Math 03, 17 and 2020. Okay, so see you guys. Have a nice day. Only copy the email. If you don't have it, you can copy, because from 9th grade there are many people that doesn't send all the homework. So have a nice day, guys. Take care.